Okay, so before we did the truth table for OR, now let's do the truth table for NOT. So our first theorem is not true is equal to false. And we're going to prove it. And remember, the way that we prove all of these is we start by writing the left-hand side, and then we'll slowly get to the conclusion. Now, before we were able to do it in one step, that's not going to happen here. What we'll do is we'll change not true to not false implies false. And remember that false implies false follows from self-implication. Okay, self-implication says that x implies x implies x, and we just set x to false, and we see that that we have this. By the way, notice that we're going in kind of the wrong direction from right to left in the equality, but that's okay, right? We can always do that. Okay, so now we have not false implies false, and we're going to change this again. So we'll say that this is equal to not false or false. And we do that by the rule called implication. It says that x implies y is the same as not x or y. Okay, so that is simply a straightforward instance of that particular rule. Okay, but now we're almost there. We'll say that this is equal to not of not false, and what we're doing is we're using the rule or identity. And OR identity says that x or false is equal to x, and xing here is not false, so not false or false is equal to not false. And now one more step, that is simply equal to false, and that is because of double negation. Okay, so this is the end of this theorem, and our next step will be to try to prove that not false is equal to true. Okay, so let's see how that would happen. So we'd say theorem, we want not false is equal to true, and the proof will go like this. We'll start by saying not false equals, and then we'll have a bunch of things, and eventually we'll end with equals true. Okay, so your job is going to be fill this in. I can't be doing all these proofs. You need to get some practice. So let's say that you're done with that. When you're done, okay, then we'll be able to build the truth table for not, and it's going to look like this. We'll have x. We don't have any other inputs. That's it. And we'll have not x, which is our output. And when x is true, then not x is false. That's the theorem I proved. And when x is false, then not x will be true. That's the theorem that you're proving. And that's the end of the truth table. That's another theorem that we've done.